All right. Hey, how you doing? Hey, Lisa. Hello? Can you hear me? I think your mic, usually it does
Oh,
this.
hi. How are you? Sorry, I was on mute.
Yeah, no, usually it does this. That's why it's like a little bit weird every time. But like, yeah, how's everything?
It's good. We just got done with HTML. It's some pretty interesting stuff.
Okay.
But
Oh, you guys did HTML. Is that, so wait, so you guys are just the actual HTML, you guys created a web page?
yeah, we created a silly web page. I mean,
Okay. Man, yeah, you guys are touching on everything. That's good. Hypertext or markdowns. In Python, I know you can do HTML language as well. Markdowns, HTML markdowns.
oh,
Uh,
really? Oh.
yeah, how was that though? Yeah, yeah. Do you know how like I think I talked about this, right? You know how like you can create these like texts, not the
Hmm.
code, but the text.
Yeah.
The text itself is HTML markdown.
Oh, okay.
Yeah, and so it's like embedded. Python is like the master language pretty much.
Oh, I wanted to share something interesting with you. I was playing around on LinkedIn the other day. You know, usually when I'm bored in my daughter's first grade classroom, I'll just play on
Okay.
random social media sites. And
Okay.
the Python inventor, he's going to go work at Microsoft.
Oh, he is? He's going
Yeah,
to? Or
yeah. He
oh
said,
wow.
he said, I decided that retirement was boring and have joined the developer division at Microsoft. To do what? Too many options to say, but it'll make using Python better for sure, and not just for Windows. There's a lot of open source here. Watch the space.
I see. Yeah, that's good. I didn't hear about that. Like that's really good because then that means that Microsoft now will in the next maybe like Windows 11 will have like embedded things in it. That's like Python language.
And
So
that'll make the data world more happier, right?
yeah. I mean, like I said, Python itself already was made to be like an open source where like everyone just comes in, and then there's HTML, and then you can use it with like other language, C++, and then like now you can create maybe hardware. There's like hardware software
Mm-hmm.
that like maybe we'll be using Python instead.
Oh, see, and I was really liking the SQL we just learned, just the regular SQL, how you just pull from you import from the CSV documents, and then you were
Yeah.
able to like pull whatever you wanted off the table. I was like really liking that, but
Okay.
I don't know what the job market calls for, but I mean, I personally I liked SQL when
You
I
like you actually like the SQL in Python or like SQL like by itself, like SQL the
the
language.
Postgres, the one we
Oh,
learned.
Postgres. Oh, that PG admin. Yeah.
Yeah,
Um.
but I'm assuming that's not out in the job market.
The MySQL is more the one that's in PG admin. I mean, yeah, they're all the same. They're using SQL itself. The only reason why I don't like PG admin is the networking thing.
Oh,
And that's why
okay.
I like using the SQL in Python because then like it's local. Yeah, this thing that you have right now, it's local. You don't have to always like like when you're creating those codes, and then just the interface with like PG admin is is like not not something I like to. It's as a matter of preference. The one thing I
Mhm.
can say is like it's always good that like bits and pieces of each language. It's always just like because then you're not gonna know everything, but if you know where to look for it, like for example, someone asks you to do some SQL stuff, you know where the documentation is now, and then what type of like what websites you have to go to look for those things, right? Or like
Mhm.
if you want to like maybe someone asks you to do something, or like, there's like a VBA database, and then now
Uh,
and like there's a database that's in VBA, but then you have to write something in Python.
uh-huh.
There's always that mix like software issue where like oh snap it's a VBA, but then you have to write something in Python. So that's why you have to know both languages.
Yeah.
Yeah, and then maybe there's a Java, Java and slash like JavaScript. So like it's always just knowing those. You don't have to know everything, but then like just know where to look for it. It will take some time to like. The other thing too is try. That's why I always say like try to do something like multiple ways is because then when you do something in VBA and you do it in like Python and then Java, if you can do it in all three, then that makes you very strong as a contender, I guess, for like a client, because then there's no weaknesses. Like they can give you like many different types of like projects in a way, and then you can understand it, and then like you can debug the code, whatever comes your way.
Yeah. So you're saying get strong in the VBA, the Python, and the Java is what to get strong in.
Yeah, Python. This especially is the one. When you're working with like machine learning, Python. Like I would just learn Python, but then know how you can implement like that same type of coding in Java, VBA, C++. And I mean, HTML is pretty broad. It's used every time. Like there's HTML language, just the language itself, like how to, make something bold, make something in color, how to embed like a video, or like a music in the backgrounds. Those are like the HTML stuff, creating that web page, making something like a picture pop out from like a web page. Because like that, when someone actually maintain the web page, and then like there's already a web page that's there, you just have to like update it.
Yeah.
So yeah, because things are already been made, you just have to like interpret it. You just have to use what you know already, the skills that you learned, and then kind of like, how do you update it? Like, you don't always have to reinvent the wheel, but it's always just the updating.
Yeah, just keep maintenance.
Yeah, that's really what it is in terms of like software, computer science, and then like this whole machine learning. The machine learning though is a whole other animal, because I don't know when you guys will touch on it, because like I feel like you should dedicate maybe like 6 months just for machine learning.
Yeah, I feel like every language I'm learning should be dedicated to 6 months, and I'm learning in less than 10 hours, and I'm like,
I know, right?
What the heck? What?
No, but it's fun that no, like that's the thing. He's giving you guys like a whirlwind tour just so that you know where to look for it. Because like, yeah, it would cost way too much, I guess.
Yeah.
That's how he gives you like, okay, here you go. This is all of it. Do your work, or do some research. Oh yeah, I did take a look at the project that you guys did. That was, yeah, that looked pretty cool. I looked at the PDF and what you guys presented. Yeah, I understand now what you were talking about. Like I was trying to kind of like search for what that meant. Like, okay, the result. So I was like, yeah, sometimes it's like that though. Like, how you guys had the hypothesis, and then like the results were like, it didn't correlate. Like there was no correlation. Yeah, I mean, it's fine.
It's fine though, because it just proved our hypothesis, and that's what the whole point of the data was, to tell the story and tell the truth.
Yeah, and then like the one thing I like about it now that I was reading the background, it's like, oh, it relates to the students, and it relates to like food, and as well as like it's something that's every time when you're doing something like this, like in a setting where you're learning from class, a lot of students will like it, because then it's it's code based, and then maybe you can use it like to you guys were doing some predictions in the end. Were you guys doing predictions in the end? I don't know if you guys did that one. I was reading it briefly, the regression stuff.
We touched a bit on it on one chart. I don't remember which chart it was, but we did touch a little bit on it, but it didn't go anywhere.
Okay. Yeah, because I remember when you do linear regression, it's like that's also like a machine learning algorithm. Like, good thing that you guys did simple like linear regression, because that right there is applied in machine learning. So if you know how to do that already, the machine learning will come easier, because then all of that is just knowing how to implement like a prediction. Like you have all these bunch of like things that you already know, and then when you do a linear regression, then you can predict, depending on like the number of times they exercise, the times they eat, calories they intake, whatever like that. And then like a student comes in, right? Like a new student comes in that school, and then maybe the machine learning algorithm can predict, okay, is this student healthy? Does depending on their background, maybe if it does work, maybe depending on their background, where if they live off campus, then these are the things that you can predict. And that's really the concept of machine learning, is now that you have all this existing data, can you predict what this new data that's coming in, can you predict where it gets classified? Or or because a lot of it, there was a lot of classification there. It's like yes or no or something like that, right? It's like yes
Yeah.
or so either one or two.
Mhm.
You were doing machine learning in a way, because then like
Oh.
because then the yes becomes one, the no becomes two, right? Something like that.
Ah, okay. Yeah, no,
Yeah,
it
because
was.
in machine learning, you have to convert the categorical to numbers so that it's easy. So you can do some math to it. When you do some math to it, that's the only way you can do it. Is you convert the words into numbers. Okay.
Oh,
Yeah,
okay. That.
actually, we may if we have time, maybe because like the SQL stuff, it won't take that long. But like maybe
Okay.
I'll touch on k-means. K-means is like one of the algorithms besides like linear regression. So linear regression is like one of those machine learning stuff, but then k-means is because a lot of people were asking about this, and it's, like the other people that I work with, like k-means is just one of the algorithms, and this will become more familiar. Maybe that's what we'll do. You know, we'll because like you have to dedicate more time for machine learning
Mhm.
to really dive deep into it. And if you guys will only spend 3 weeks, maybe he'll touch like 10 algorithms in a day, which is like impossible to learn.
Yeah.
There's a bunch of
Yeah.
algorithms, and then like if he just touches on them like one time, it won't like it won't sink in.
Yeah. No, and that's been my problem with this whole class is like it's so fast paced, which is fine, but
Yeah.
it's like now I'm realizing I'm like, oh, maybe I should go back to like call my college and be like, hey, can I take can I get
Oh,
another
oh yeah. Oh yeah.
get another degree?
If you want to do that, there's actually if you want to just search your nearest community college, whatever.
Uh-huh.
This is just an advice because I'm like I did this before where like you go to community college like while you're still working, and then
Mhm.
like take online classes from their community college, which are really cheap, right? It's super cheap. That's why.
Yeah. No, because I'm honestly contemplating that. Like, I'm like, okay, if I can get a job out of this, like, entry level type, that's fine with me,
Yeah.
I'm like,
Yep.
and if I know I start getting the experience on the job, I'm
Yeah.
like, maybe
Yeah.
I should take something at night to kind of, really fully grasp this whole thing. Because I don't like the fact that it's like so fast paced
Super
that I'm
fast.
like, wait, I just figured out what 1 + 1 is. Like, how are we on
Yeah.
10 + 10 already, Like,
Yeah, it is like that. But then, yeah, I definitely suggest that because, like, I know a lot of people are doing that as well. Because, like, but then minimize the cost, which is going to a community college, right? Community college is like, and it's online. I think the one that I went to, everything was online. Even though before this whole COVID thing, everything was online already.
okay.
So that was great, right? Like, you can work and then do it online, and then online for the one that I don't know if you oh yeah, you probably know you know Allen Hancock College, and I don't know if that seems familiar.
No.
Yeah, you could. It doesn't really matter, but like I think there's other colleges out there that like when you search for it, it's community college. There's an option every time because there's an in-person part, right? Obviously,
Mhm.
and then but they always have a section just for online, and then online can be two things, like two types, like either it's synchronous online or like asynchronous online, where you just like they give you all the bunch of like stuff to do for that week, and it's on your time whenever you turn it in. But the one thing is you can dig deep to it. You can take your time, pace yourself, and like you obviously get graded, but it's not really harsh though. It's not like super hard. Like the grading is not super hard because it's more of like the one thing that they wanna like give you guys is all the resources. So they'll give you all the resources at the minimum cost, and then at your own pace. And then for example, this machine learning stuff, all the algorithms, you'll probably spend like 2 weeks for each one. So like 2 weeks per algorithm, and then per language, maybe you'll spend like maybe 10 weeks per language if you want to take like a Java for 10 weeks
Okay.
or like Python for 10 weeks. Yeah, those are the ones I like because there's ones where it's like where there's even one where it's like 4 weeks, but obviously less time would mean more work, right?
Yeah. No, and honestly, that's how I got my bachelor's. Is I went through an online school, and it was like,
Oh, nice. Yeah,
and well, and it's because mom working, I didn't have time to do the normal
yeah,
going to the university, but and it was fine.
yeah.
I mean,
And
I
then
owe
like I
60
always say
grand
like
now, but it's fine.
it doesn't matter where you get your degree. It's more like you gotta. It's it's just a paper, right? Like,
Yeah, that's how I
yeah,
feel at this point.
it's like, oh yeah, that's good, and now you can relearn everything.
Yeah, no, that's how I feel at this point. I'm like, okay, I got the paper, but it's not getting me anywhere. And like I told you, at my pre-COVID job, I was already headed into data analytics for the sales team,
Oh yeah,
and
yeah.
I was
Yeah,
like,
that
okay,
data analytics definitely that's the one. Yeah, I mean, there's always the data like analysis is
mhm,
always like prevalent. There's always a job for data analysts,
yeah,
especially I guess we yeah you know how the whole this whole voting election thing that's a data analyst thing too.
mhm.
Like a lot of people now I think what would say that the data science is in fact very important. Yeah.
Yeah, but I think some of those people need to learn how to code better, personally, because it's like, how are you? These are your numbers, but these are actually the numbers. Like, how did? But besides the point, I was just like, okay, but yeah, I mean, like I said, I have a bachelor's just in business administration, just the general degree, and haven't gotten anywhere with it in life. And I'm like,
Yeah.
okay, well, let me try this boot camp to see if it'll
Yeah.
actually get me somewhere. And I like it. I do. Don't
It's
get me
good.
wrong, but
Yeah.
it's so fast, and I'm like, I
It's
can't
super
catch
fun.
up.
Yeah. Just to like the boot camp itself, I think it's more expensive than the community college actually. Like the community college ones, I know that in fact it's only like 100. It's only like 100 or even like less than that for like 10 weeks. It's crazy actually how cheap it is.
Okay, yeah, no, I'll look into that. I mean, like I said, if I can get a job, even if it's entry level, which is
Yeah.
fine with me.
And then the thing is you learn so much. The funny thing that people don't think you learn so much in like community college is like, oh yeah, let me go to the highest university, learn a lot. Like spend so much, yeah.
Yeah. I'm already like I'm like 75 grand into my education. I'm good.
Yeah, and then you can do it on your own time. When you do it on your own time, and then you get to see, and then like all these different things, and then I think the videos you can save on your drive, so that you.
Hmm.
The one thing about online, other thing is like, you can always go back to it. Like,
Yeah.
because if it's in person, it's that point only in time, right? And then you're like,
Yeah.
oh, okay, and then you refer back to your notes, which is like 50% of what the professor talked about.
Yeah. No, and I have no issues with online. Like I said, I got my bachelor's from
Yeah,
there. So I mean, and it did me good. I mean, I worked on my own pace. I mean, when I had to take a break between, from one class to the next, I would
yeah,
tell my counselor, like, I'm like, can you just give me a week off so I can
yeah, yep, yeah.
collect my thoughts? And it
Very,
worked
very
out
flexible.
great. So
Yeah, it's very nice. I do like it. Some people don't like it because like the one thing I think what people like is like online is good if you already have the background of your whatever you're doing,
mhm.
because then no one has to, and you already know how to teach yourself. Like, and then some people say, okay, I don't know how to teach myself, so I don't like them. But like when once you just like that's the one thing that they feel like apprehensive, like, oh, I don't like doing it. But once you start doing it, and then like, oh yeah, this is actually pretty good, and then like you can gain experience, right? Because you're still working.
Mhm.
You don't have to like get out of what you're doing.
Yeah, no, I liked it. Like I said, it was at my own pace. There were some great classes. There was not some great classes, but
Yeah, there
I
were
I,
the more
I
advanced.
liked it.
The hardest thing is probably when the professor, because like that's the thing. There's programs where the professor knows that everyone is working, and there's other programs when they're like, screw you, I don't care if you're working, you have to turn it in.
Yes, and I've had some professors like that, and I've had some professors are like, "Hey, life is happening. Like, I get it." You
Yeah,
know. So,
yeah,
and it was like, okay, well, I understand. I understand if I'm not going to get, I'm going to get points docked for submitting this assignment late. I get it,
yeah.
but thank you for understanding. I have a life too. Like,
Yeah, I know. Yeah, I know what you mean. But I always grind through, like, I always try to do, I guess, ahead of time. Like, okay, is that a good program to be in? Because sometimes, yeah, that happens. Anyways,
yeah.
okay,
But let's
let's
talk
talk.
sequel.
Okay, so SQL using Python. I think you guys already covered this, but let me just, I guess show you what I usually do.
Yeah.
So depending on what you are doing, you always import these libraries, right?
Mhm. Mhm.
I
Or
think we're not even gonna
dependencies.
do like these other libraries. This is just what I usually put in. But the one
Yeah. No.
thing, the most important thing is this guy, SQL.
SQLite.
Yeah.
Mhm.
So here, this is the one, and then I guess you're gonna be working SQL with like PD, yeah, with pandas.
Mhm.
So the combo here usually is pandas and SQL, and then just to like drive the thought is so you know how like pandas you create a data frame, right?
Yes.
And then like SQL is just but then is also creating another data frame in itself. You can create it in the SQL world, but then with the pandas, it's in like Python,
Mhm.
So, And then what ends up happening is it's just pretty much you're just passing things through. Like you create it in Python using pandas, and then you pass it into this different type of environment called SQL. And then so that database is the same. So when you pass it through, and then the way you create it in pandas is pretty much very similar to the way you create it in SQL, but then like just a different algorithm. Yeah. Okay. So like I guess the very first thing I usually do is oh yeah, I didn't show you what this example is. So this example, well, there's like 4 databases or data sets. So there's 4 Excel files. Is like this is invoice, and then what you see here is like invoice number, store ID, whatever store number they are, product, whatever. And then the other ones is the details doesn't really matter. I'm just showing you what they are. So customer data. I think for this one, what we're gonna do with them is we're gonna combine these, all 4 of them. So there has to be something that's similar. So the customer ID is similar.
Yeah.
And then let's look at the other guy. And then this other one is product. So I think the product ID is also in the invoice. So that's good. So you can combine it. And then you also have this like store.
Paul, are you talking? Because I can't hear you.
You can't hear me?
Okay, now I hear you. I hear you.
What happened?
I don't know. I just saw your computer moving. And I'm like, he's not talking.
Oh, okay. I know I didn't mute myself.
So weird.
Yeah. I don't know. Maybe it's a connection. Okay.
Yeah.
So did you hear the other data? That there's 4 databases.
Yeah. So are we doing like the pd.combine the data frame?
Yeah, we're kind of what we're gonna do is we're gonna use SQL for that.
Oh, okay.
That's the main thing here. We're not gonna use
not the pandas.
Yeah, we're not gonna use pandas. But then what I'm trying to do is I'm gonna create it in pandas, and then I'm gonna pass it to SQL.
Okay.
Yeah. So all 4 of these are here, and then they all have something in common. So that's good. You can combine them. I think the invoice one is the one that we're gonna combine it in invoice because it has pretty much all the different labels or columns. And then so that's what I did here. ICPS, invoice, customer, product, and store. And then this is the thing. When you're creating a SQL database, you have to do this offline, like out of this like environment. You have to create this different notepad file, this .db. So let me just show you. Like that's what I did here. I have pretty much the notepad file, which is this guy. So ICPS data. And then
so this is just like pandas where you pass it to when you're trying to pull the data.
Exactly. Yeah. So there's a connection there. Okay. How you would create this connection, the SQL connection, is you have to it doesn't have to be this name convention that I have. It just has to be something that you have to create in Notepad.
Okay.
So you open Notepad and then there's nothing that you put in here because we're gonna fill it in. Mm-hmm. But what you have to do is you just save it, and then like go to whatever. I already have it here, ICPS. Mm-hmm. And then when you do this, it's ICPS.db. Whatever you're gonna name it, make sure it's .db. And then you save it. But I already have it, so I'm not gonna.
Yeah.
It's right here. Sometimes it gives you an error because that you can only fill this in like once. So let's see if I have to recreate it. So let me see. So let me rerun this one, and then let me rerun that. Okay, and then let me rerun this one. Okay, so that's good. So I created that, and then this next thing right here is I was typing this really fast. So this is like a tool. This is a tool that can't type. It's a tool that executes SQL code against the database. So this is the guy where when this syntax right here ends up happening. So you created this SQL database, right, by creating this empty file, and then you're gonna apply this this SQLite .connect because you're creating this connection with SQL, the Python SQL connection. And then once you do this, then you create an instance of it by doing this. It's kind of like this is your current database now. Like this is your current, so you do db.connect.cursor. So now you created where you are. So these 2 things you have to do. It doesn't have to be the same name, but you just have to create the connection and create an object or an instance. of your database. So these two you have to do because you just have to do that before you do any SQL stuff.
Okay,
And
yeah,
then,
the CON is the connect, which is similar to pandas combined.
yeah.
Okay.
And then let me actually run this if it can. Oh yeah, see, it didn't work because then it was already created. So let me actually delete that. Actually delete this guy. And then exit out of this. Because you can only create it once.
Yeah.
So, and then let's actually open that again. And then Notepad. And then make sure this thing is in ICPS data.db. Cool. All right, it's there. And then so run. Good. Okay. So now you have that. So these next four is just gonna create the different tables. And you've done this in PG admin, these different tables, yeah?
Mm-hmm.
It's pretty much the same syntax, but now you're doing it in Python. So you know, this first one right here is you're gonna have to create this. The one that you're gonna create to for your foreign key is gonna be the primary key is gonna be the main guy, which is the invoice. Like I said, it's gonna be the main guy, right? Because you have all the columns.
The primary key is the main one.
Yeah, exactly.
Okay.
That's hence primary.
Yeah, that's what I figured, but it just didn't click in class. Okay, and then the foreign key is the other backup documentation.
Yeah, but then these are the different like words for them. What I usually just say is like this: the main guy has to have like all the columns that these sub guys have. Yeah, that's how you create. Well, which one is the primary key? The guy that has all the other columns that you're gonna combine them with. And these foreign keys that references like, you know, like they're gonna be combined with the invoice. So that's why you do it like this: the foreign key, all the other ones. And then like the main key is the one that you're gonna combine it with the invoice. Or it could be anything that's the main guy. So like the syntax is pretty simple. Yeah, like it just tells you the different columns, and then right. I don't know if we actually didn't talk about this, but like, you guys talked about it in class. Yeah.
Yeah. Can you kind of go over that? Touch.
Okay.
Briefly on it.
Okay. So yeah, that's what I intended actually. I didn't know how much you guys covered, but. So,
yeah, no, we did, because you know when you do the coding, you had to hit not null, which I didn't understand.
Okay.
Personally, I didn't even understand what varchar was. If it wasn't an integer, it was a varchar. Is from what I understood, and then I gave it 300 characters each time because I didn't know how long each character was in the column, so I would just
you could do
300.
That's good. You could do that. Yeah, like when you do car and then whatever number, you know, because then you yourself, you don't want to be like searching for all the, you know, like one by one comparing it, right?
Mm-hmm.
So just pick like the most, the highest number, the most conservative number, to like account for everything, and then when you can come back and just like change it once you like, oh, okay, maybe I can make this more precise or more efficient by making the, you know, the preliminary like smaller. Anyways, like so when you create this invoice data in SQL, this mic here, this instance, the object that you created, you're gonna fill it in. So that's why it's like the same exact variable as what you did as object, and you do .execute. That's the syntax, .execute. That's the command pretty much here. This whole thing is inside .execute. And then what you put inside, it's kind of like what you did with doc strings. You always start the syntax with triple quotation marks. So like triple, like, or 6 apostrophes, whatever.
Mm-hmm.
And then like what you put inside, and then, so that's how you begin it, and then that's also how you end it. The reason why I'm writing it this way, because like it's easier to read rather than when you stack it horizontally. It's really difficult to read. Like you don't know what the heck's happening. So if you stack it this way, it's easier. And then Python doesn't really care about the white space. This is interpreted the same way as if it was horizontal.
Oh, and you know what? I think we were taught it to do it horizontally because you have the commas to the left, and we always put the commas right after we.
Yeah. You can do it that way as well. Yeah. But this will run. I mean, either if you put the comments here or after each of the statements,
Mm-hmm.
you could either do it that way, or I mean, there's multiple ways, or you can like not not obviously enter, just like run it all the way through off the page. It's just harder to read because you have to scroll it. But okay, and then so after the quotation marks, you have to do it this way, like create table, and then this I right here, whatever you put here first, this is the I for the one that you created in Pandas, the database, the data frame name. It has to match because you're gonna put things inside because you're creating a table, and this is the I from the I that's already like created, and whatever you put inside. The one thing about this is I always see this as like it's a function within a function. So you have like this execute function that's gonna fill in your cursor object or instance of your SQL database. And then so when you create the table, you have another parentheses because you're gonna fill it in, which is this is the opening parentheses and this is the ending parentheses, right? And you're gonna fill in the table now with the keys and then the column data type.
Yeah.
So the very first thing I usually do is so the first thing here, if you look back, you always look back to like your data right here. And then know what kind of data are you filling it in or what do you have.
Yeah,
So,
the invoice is an integer.
yeah, and then the store ID right here is a text, right? Not null. So when it's a text not null, that means you always put that text not null.
Okay, so it's always text and then not null is usually followed. That's just a standard boilerplate.
Yeah, boilerplate stuff. But when you put in text, every time you always do that. And then for, let me see, it's like product ID and customer ID. Yeah, that's good. And then for dates, the other boilerplate stuff it's a date. So the SQL thing knows that if you put in date, oh yeah, always know when you have to make these all capitalized. That one.
Yeah, SQL's always capitalized. Or
yeah, like the main commands, the commands itself, it's capitalized.
Mm-hmm.
But then the thing is that you're combining languages there. So you have the Python language in white, and then the SQL language in whatever color this is, right? Brown. Okay. So like that's why you have to know what are the syntax for each language. That's like the lesson of the day is like knowing when to the language syntax, which is like what carries through the end is there is different syntax, and then when you look back, because you're gonna get an error, right? I mean, if you make this all lowercase, it's gonna be wrong.
Yeah. Okay. Sorry. So what does the not null mean? What is that whole purpose?
Not null means so null means empty, right?
Okay. Okay. So the text isn't empty.
Yeah, that's pretty much what it means. Yeah. If it's an empty one, like maybe there's nothing in it, which is like would be weird. Why would you create a column?
Yeah. Okay.
Yeah, maybe put it as null. Anyways, and then date itself is, let me just put this like this. So date itself is another syntax, and then unit is a real number. So real, and then real is just when you, let me see, price. They're saying that this is an integer.
It's not a float.
Yeah. And then like, cause like a real is pretty much just an integer that has no, if you remember imagining numbers, whatever. So like you could technically put unit as integer. It wouldn't matter if you put unit as integer. You don't have to put it as real. And then like if you do like promotion, obviously promotion 2, they're all like integers. It could also be real. Index 1, index 2. You could either put real or integer. The one thing I think, isn't there float as well? You guys learn, is there a float one? I forget if there was.
Yeah, we learned float, and it's usually float is a decimal.
So for float, you could use float. Like for example, price here could be float.
Okay.
I mean, it's whatever you want it to be, because what ends up happening is like you're just filling this in, and then it's gonna put it. No, the reason why I don't like this is how in Python you never define the data type. You never do.
Yeah.
and then like now you're mixing it with SQL, you have to define it. So, I mean, in programming language, the fundamentals is you have to know what you can put in a variable. So I guess it's good practice to know what these are, like what you can how to define them. And then after you define the data types, like I said, primary key, the main guy is invoice, and then the sub guy is foreign key. and then you just have to, when you do this reference thing,
Mm-hmm.
the reason why we're doing this is so that we can say that this store ID is inside this S guy, the one that we created here. And then this P guy, which is this data frame that we created here. We're just associating it. So you're associating, you're referencing this database with the key of the store ID. And then the key of the product ID, key of the customer ID is associating it with the actual database, the CPNS. CPNS. Okay, and then that's really then the last thing is you end it with this is ending the SQL, and then this is ending the actual like SQL language, and then now you have this whole guy, right? And then that's it. You pretty much, there's no output because the only thing here is that you're gonna put it inside. There's nothing here because you're just defining these guys. And then you do the same thing for which one is this one? For the customer data. And then you do the same thing for the store data. And then the product data as well. Oh yeah, I already ran that one. It's always different to look at it. I'd rather do it in the Jupyter notebook than like VS Code. Okay, good. All right. So now, like after you define those, so does that make sense how you define each one? Like that?
Yes.
Syntax? Okay. Yeah.
Now I understand the primary and foreign key like a lot better.
And then the primary foreign key, you only define it in the main guy. All these other guys is just this guy, yeah?
Yeah.
You don't ever define the other ones. So, okay. So like after you do that, now let's actually transfer. So this is I actually alluded to this. So where you create it in the Panda in Python, pandas in Python, and then now we're gonna transfer all these things into SQL now. So SQL, how you transfer it from like Python to SQL is, this is the syntax.
Oh, okay, yeah. So because that was the invoice, to SQL.
Yeah. So it's really simple, right? Like it's this _SQL is kind of like what you did to save a Panda data frame. This is a kind of similar syntax to like CSV. This is very similar. So yeah, the name of the data frame in pandas, and then to SQL, boilerplate SQL transferring. And then like the first argument here is what you're gonna name it. I mean, I would just, like name it this, like this is why I name it I1, C1. And then these other ones, the second argument here is what your connection is, the SQL connection, whatever you can name it here. Because this is how you created because this is how you're pretty much gonna connect with Python to SQL. You always have that there. So the first argument.
Okay, so because SQL, the Postgres, you were able to import it.
Yeah. And then when you do it the Python way, this is pretty much connecting to the SQL world is when you created this DB connection, it's going to connect it to that.
Okay.
And the first argument here is the name of the SQL data frame, not the Panda data frame. And,
okay.
Yeah.
That was at the top, yeah.
Yeah, and then this guy right here, if it exists, there's actually this thing where you can make this not append but replace. And then like you could play around with it. The reason why I put append is that this is the beginning. Like there was nothing in it, right, when we created it. Like the notepad that we created, there was nothing in it.
Oh yeah, there was nothing. No.
Yeah. So if it exists, if there's something in it, you append. This right here is boilerplate, but you can change this whatever this thing is. You can either change this to append, replace, or I think those are the main ones that I know. Is when you append it is when there's an existing file, it will add to it. And then like you have to be careful sometimes to check like, okay, because when you pass it, you're not doing anything to it. It should be the same exact data frame, right? Same number of rows, same number of columns, right? When you yeah. But when you have this as append and you redo it, it's gonna add another row. And then you're gonna be like, why the heck is my average wrong? Why is my data not matching up? So you're probably wondering, where is this coming from? And so the best bet I would say is like change if exists to like equals not append but replace. Because like when you rerun it in Python, it's really easy to rerun things. But then when you have this guy with append, it's gonna double your data, double the number of rows, double the number of columns, which is not what you want. You want it to be the exact number of columns and rows. So when you see that error, just change this to replace instead of append.
Okay, and then why is the index false? Because it does have a.
Yeah. So this index bar boilerplate, same with the Python pandas, where if you don't want the index to show up or the header, whatever, you just make it false, right?
Oh, okay, okay. Because I was like, there is a header, but you don't want the header to show up. Gotcha. Okay, so that's why it's false.
Yeah. And like, let me see. And then after that, let's actually read the data and see if it's pretty much the same thing as the pandas. When let's say that you're combining. So after you transfer it over, you now have these data frames in SQL, right?
Mm-hmm.
So now we're going to actually use these names. We don't have to use these other names that we use in Python. But it's kind of funny because then you still have to use PD. So
yeah, it's because that's PD read. That's just pandas. But okay, but you're doing SQL because you select star
yeah,
from. Okay.
yeah. So when you do PD, you're still doing PD.read SQL. But you kind of like if you look at what's inside here, this looks familiar, right? Select from.
Yes.
Yeah. So this is another combination, like hybrid like syntax. So like PD read SQL, just know that that's like boilerplate. In here, what's boilerplate is up to the only thing that changes here is this guy, like this.
Oh yeah, because
one.
you want to limit how many rows you want.
So you know how like in pandas you have like head, right, and tail.
Yes.
Yeah, here this is what you do.
It's just type in how many you want for the limit. That'll be your dot head.
Yeah, I think there's also a way to do tail. You can experiment, maybe make it negative. Who knows, You can probably make it negative and make do the tail. But for the most part, yeah, like the head is already gonna help you. Yeah, I mean, like look at this. This is pretty. The one thing I like about this is like you can see the relationship. It's like, oh, I've seen this before. I've seen this output before. And then now you can use pandas or you can use SQL, right? And then you can even make SQL stuff appear in like Python. So like yeah, like now you have 4 different databases and they're all in SQL. So it's in here. So now let's actually talk about like the main thing, which is let's actually use the SQL data like here, and then try to combine things like the way we would merge, and like kind of. I mean, we're not gonna do the full merge. We're just gonna merge like a few columns, and I think that's like one of the ways like SQL is good. I mean, in pandas you can also do that. You can like filter the columns that you want and combine them in like a new database or data frame. So in SQL, you can do something similar by using like this left join thing. There's also a right join, but then there's also a join in pandas, but we usually use merge. So like yeah, like let's just look at this one. So left join invoice with product SQL tables and print. So like in layman's terms, what I'm trying to do here is I'm gonna join the invoice data frame into like the product data frame, and then most of these will join it from we'll reference invoice. We're gonna be using invoice because it pretty much has all the columns. So what I'm gonna do here is I'm gonna join the customer ID in this guy right here, the customer ID and invoice, and as well as so that with the product ID. So if you look at product, let's look at product. So since the product ID matches with the customer ID, that's really easy. You can do it that way. It matches. So what I want here is I'm gonna join this customer ID with the product ID and the product name, product type, or product name. You can also put product type if you want to. But because there's a direct correlation between product ID and customer ID, you can definitely do that. So, the syntax is really easy. You guys probably covered this one, right? As well.
Yeah, we did, but.
Okay. This one will actually. There's some parts here that may not be common, but so like the left join, what you do here is obviously you create a variable, and then a lot of this, like there's always this quotation mark. It's like a string, and every time you're typing a SQL language, there's always a string. So when you do it, you just one quotation mark, and then the way I'm writing this is like I like to do it this way where you can just like tabulate or like enter for each line. It's easier to read, as I said. So you write select first, that's boilerplate, and then the slash, and whatever you put in after this guy right here, this is gonna be what you're gonna put in your for your first column. Whatever column, the next few things is whatever columns that are gonna be combined. So the first column that you want from the I1, which is the invoice SQL data frame, you want the customer ID. You only want the customer ID. So you want this guy. You want this guy right here. And then the next thing that you want, because you want to do the associate the product ID with the customer ID. So you're gonna want the product ID. And then something that's not an invoice is the product name. But then you have the product ID to correlate that. So now the product name is in here. So that you have to reference the product that SQL data frame. So that's what we did. And then from invoice, the next thing, the boilerplate stuff is from invoice, because this is kind of like how you're gonna merge them. This next part is how you're gonna merge them. So from the reference guy or whatever, it could be the other way around. It could be from product. I'm gonna do a left join, which is the syntax for it. So whatever comes after this left join is whatever you're gonna merge, right? Like you're gonna merge the invoice with the product. So that's how you do merge. You have this like left or on right, like in pandas. Here, this is the direct correlation with the merge. So you have from whatever the first thing that you're gonna do, left join the next thing that you're gonna combine the first thing with. And then after this and on what are you doing here? So the one thing that you want to correlate them that they both share, the invoice and the product, is the product ID, right? They both have it, right?
They both have it, yeah.
Yeah, or whatever it may be. It could be something else, but whatever they both have, they have to have something in common. It's like that's the only way you can merge it, or else like what the heck are you doing? There's no way to correlate them. So same with like left, on, or whatever in pandas. There has to be something that they have to have in common. So no difference here. So product ID on the invoice and the product ID on the product. And then after that, you suppress it with a colon. This is the first. This one, like after you do this, this is pretty much the code to do the merge or the joining. And then now the next couple things is just plotting it, or not plotting, outputting it. So you could technically output this left IP, but I just decided to do a for loop. You could just output the left IP, like print left IP if you wanted to, or whatever you put this inside. But what I did here is I wanted to print them in a way where for a for loop. So what you would do is like whatever you put all this inside the SQL object, right? This my curve, and you do this execute thing again, and then whatever you put inside is this guy, whatever you created as your merge data frame. And then you have to do this my curve fetch all. So this my curve is very important because this is what you're always referencing in order to do something to the SQL like object. So now after you place the data inside this object, this SQL object, after you place this guy, you want to fetch all of these and you put it inside my result so that it transfers everything inside, like from your the notepad, whatever data frame that the notepad file that we place. You fetch all, you put it inside my result, and then now this my result has all of this guy, right? These are all the guys that I have, and the only thing that I'm doing here is I'm printing each row, which makes sense, right?
Yeah.
Yeah. And
okay.
So I'm just printing each row, individually, just to show you like what it means to join these guys.
Okay, and it's a for loop, so it's running through each row for whatever columns you're calling out, and if there's something there, it prints it.
Yeah.
And if there's nothing there, it kind of just skips over it, or it ends the for loop, right?
Yeah. That's yeah. That was a long time ago. Yeah, that's what a for loop does. Yeah. In essence, yeah, it becomes very natural like later on. But that is what it is, right? Like that's why we always use for loop. We never use like while loops in essence. It's all because you know already the length of this guy, and you're just gonna each one of these, it's gonna go to like it's a list. It's gonna go inside here, and it's gonna print each row. Whatever is in X is each row. So it's gonna loop through each row, pretty much, until it ends. And like, so does that make sense? The main thing here is I'm doing the join, like doing the join for one. For this one, is just doing a join and not doing any other math things. But does this make sense?
Yeah, I'm following.
Okay,
Like,
good. The next one here is let me see if this is the one. Is this with the store one? Yeah. Okay. Kind of similar. Let's do that again, just to like concretize what we just did. So the invoice table, the one that is the main thing here, is gonna be combined with the store. Let's look at the store one now. So the store one, let me just do this one. Okay, store. So the store is pretty small. So let's see. The store ID is also an invoice, right?
mm-hmm.
Store ID is an invoice, so that's good. You can correlate with whatever we have here. We can pick any of these columns that we want and add it to this new data frame. So let's take a look at this one. So this is the name of my SQL data frame, and then like I mentioned, the way you create this merge thing is you do this select first, and then backslash whatever, and then you first define whatever you want to put inside your merge data frame. The first thing I want is the this is from the invoice, the customer ID, which is what we're gonna use here. And
Okay.
and let's see. So what I did, so when you do the first one here, I didn't put, there's something new here. When you say ask customer, this guy right here,
Mm-hmm.
this is just something extra. You don't have to do this.
But
so
isn't that when you define like a variable?
yeah, you can define it as you can change the name of it as a variable.
Okay.
So this one we didn't have to. You don't have to do it, like I said. Like you can still create the same exact output. It's just when you put in like as, so you're putting this guy inside customer and all these whatever you want, yeah, like
Mm-hmm.
after as. But that's just another element. You can do that. So customer ID is the first guy, which is right here. Store, and then from the store data frame, you have the store name.
Which is column B, yeah.
Yeah, and then store size. So like in the other one, we had the product ID. You know, I mean,
Mm-hmm.
obviously, like that one is the one that we're gonna reference in both. And then for this one, it's store ID, but you don't have to have it as an output. I mean, it's up to you. So, but then like you can correlate this because the one thing that they have in both is the store ID, right?
Yeah.
Yeah, and
Okay.
it's the same thing. So after you define whatever you want in your merge data frame, SQL data frame, then you put in, like, now you're going to combine them. So the syntax is from, the very first one, which is the invoice.
Mm-hmm.
I'm going to left join. Whatever comes next is what you're going to join it with, which is the store one. And then now the invoice is going to be joined with the store with these columns, specific columns. And then whatever is after this guy is what you're going to put it where they have the reference column, right, that they both share. So the invoice and the store has both the store ID, right? So both of them have the store ID. So that's why you can combine these, because the other one, you combine them because of the product, and then this one because of the store. Very similar, right?
Store size or store ID?
Store ID.
Oh, okay.
Store size is only in store data frame. Like
Okay.
store ID is the one that they both share.
Gotcha. Because I see the 1600.0 and I was just looking at that transfer. Oh, store size. Got it. Never mind.
It is, right? Store size. We could have added that. That's why I don't like when you put in, like, this one is pretty clear. You have the PR.
Yeah.
Yeah. Like I said, it's up to you. You could do that as well. You put the store ID. I just didn't choose to do it. I think I did it with the other ones. And then so that right there is like the main thing, for both of these. The main thing is learning how to combine it, not using pandas, but doing it in SQL. And yeah, I don't think it's that bad. It's just a bunch of other things that you have to remember, which is the select and left join from. And then like over time, you can remember what these are, and then like how to output it, right?
Mm-hmm.
And then also how to create a SQL data frame from pandas, and how to actually create the actual data frames in SQL. and then how to pass it, how to pass it from like pandas, or like how to initialize the data frame, the connection from SQL to Python, and then this also remembering after you create that connection, you need to create an instance of that of the object, create an instance of the object of this connection. You can't just use this connection. You have to create an instance of it, a cursor object instance. And then that's going to be the one that you're using, not the connection. You're going to be using this micro, and you're going to fill in all these different types of SQL data framing, and you're going to put it inside, as what we've done here. You're going to put it inside after you do a lot of these like edits. So the edits is just somewhere in space, and then when you pass it through, you do dot execute. Same with when you're creating it, dot execute. Okay, so that's joining them. Now this other part, let's look at this other part. Because this other part is interesting. This next ones we're gonna use. We've done this in pandas as well. When you can aggregate, right? That's the word for it, but it's when you're.
It's like a group by though.
It is like group by, yeah. That's what it is. You're gonna see that is what you're gonna do, and you can actually sort it as well. So now you have the merging them. After you merge them, you do some cleaning by doing aggregate or group by, and then now you're gonna sort it at the end. Because now that you have it all like organized, and that's really the name of the game, just organizing the existing data, yeah, and then trying to configure like how they did it. Okay, so with this one, let's see. So with this one, I just use one variable. So here you go. The one variable here is this guy. I think we're gonna cover two variables as well. So like one variable meaning like one column. Variable meaning like here I mean by that one column. So I'm grouping this by one column. That's the context of this. Like what does one variable? I'm grouping this by one column.
Okay, so you're using the word group by instead of aggregate.
Yeah, okay. And then so there's two variable thing, two column. I'm grouping them by two. So I group them by one, and then you can have as many as you want. Group them by one, group them a second time by another one, and then whatever, so on and so forth. So when you do this, same exact thing. Let's just look at what we did here. So select, and then you create the whatever you're gonna put inside, customer, product ID, and product name. This is like the first one that we did. And then like now, you know how like you can add columns in pandas, right? You can add columns in pandas. You can do it here too. It's really simple. You just do it like this as thing, the one that as. You do it by doing this. You create the name of it, because in pandas you do the data frame, right? And you put the square brackets and then the new name, right? The new name, and you equals it, and then whatever comes after the equal sign is some math that you do with the columns. And then when you output that thing, then you have the new column name, right? In the SQL world, you have to do or SQL and Python, you have to do this as, and then as whatever you put after, it's like the switch pretty much. Like whatever you put after is like the name of it.
It's the new name of the column.
Yeah, and then whatever.
Instead of doing like the whole dictionary quotes and colon and then new quote.
Yeah, it's like just knowing those small stuff, and the code really exploits that. Like, do you really know your small rules? Because then like it won't run. But like the sum, so the sum is another function that's within the SQL. So when you sum I1.unit. So what is this? What are we doing? So the unit here is the unit price, right? The unit price, which is this guy. Yeah.
Okay, column F.
So the unit price, what I'm trying to do is, because each one of these, if you take a look at like really look into like this data, each one of these has a different customer ID, but then some of them have similar ones, right? It repeats, right? Look at it, it repeats.
Yeah.
And then like, so this is not organized, that's why. So that's why I wanted to group them by the customer ID, so that it only shows up once.
Yeah.
Customer ID only shows up once. And what I mean by summing them is sum them for each customer ID. So for all the customer IDs you see, you're gonna sum all of them, the unit price for and then so that's why I'm saying sum it so that it only shows up once. And so like that's the new thing here, pretty much just this guy. And so like after that, from I1. All this is pretty much the same thing as we already talked about. So this first part here is from I1 left join P1. That's just joining the invoice to the product SQL data frames. What comes after on is the reference SQL data frame column name, where they both share. Invoice shares product. Invoice and the product share both the product ID column name or column. And then so that up to that point you know it, and then there's new stuff, the group by.
Mm-hmm.
This is the part where you're gonna organize them now by the group by, whatever comes after group by. So the group by here is gonna be the customer ID. So that's gonna be the thing that only shows up once. So I group them because there's a bunch of them here. I group them by customer ID, and as you can see, they only showed up once, right? Because I grouped them by customer ID, and then for each customer ID, let's see. Yeah, for each customer ID, what I want to do, since it will still follow what you mentioned here, the order that you want the merge data frame to look like, it will still follow that.
Yeah, I'll still follow the column order of what you're calling out to do. Okay.
But if you look, because we already did this one, right? We did this before. We did it here.
Mm-hmm.
So when you take a look at this, yeah, I mean, like, it's longer, obviously. What you did is after you apply the group by, it will reduce the size of this, and then it will just show you more. And then let me see what else we didn't do. Okay, so this is the same. The third column here is the same, the product name. And then this new stuff, the fourth column, this is the sum, right? The unit sum. So kind of similar to like when you add like the column, it will add it to the end. Because where you put it here, where you put it here is where it's gonna add it. I think I guess it's flexible. If you do wherever you place the sum, you could place it in the beginning or in between two columns, but you place it in the end. But just to track what's happening here, that is what it is, right? This is the sum, the unit sum.
Okay.
And that's it. Like someone can ask you for each I want you to organize all these database into like the customer ID, and then I want to know like which customer has like the highest unit price, or like lowest. And then maybe something that there's a trend that you can do, and then maybe you can update that for next year because you're losing money. Okay, so that's pretty simple. That's just another element to the left join you can add, because now you learn how to join them. You can filter, you can group by them, right?
Yeah. Okay.
But this is just using one variable, right?
Mm-hmm.
So one variable, obviously you can extend this. So let's try to do that. Because yeah, this, like for example, if you were just to like think what you can do, so you group them by customer ID, and if you look at this one, look at this product ID. There's that guy, and then it repeats again, right? There's another one right here.
Yes.
So what if you group them by something else? I think I didn't do it for the other one. It's gonna be different, but you could certainly do it for maybe what you wanna the syntax for adding another variable is just adding it here, comma, and then the variable name, like the column name. So, if you want to do I1 dot customer ID, then comma I1 dot product ID, something like that. And then that will group them by this guy as well. Okay, let's take a look at the other one. So this is the second one. I think, let me see if this is the one that we're going to work with. The other one. Product. Customer product name, I see. Customer store size. Okay, customer. Oh, so I did product ID. Okay. So this, it's kind of similar. So this next one is going to be, oh, I did 2 and 3. Did I do 3? Okay, I did 3 as well. Okay. So I guess just to extend it. So 2 variables, same thing. The only difference is, but this is a different data frame. So the only difference is, like I said, you add the comma here, right?
Mm-hmm.
Everything else pretty much exactly the same. If you got like everything up to this point, it's pretty easy because the other thing is this average stuff. Besides doing sum, you can also do average. Like other statistic terms that are like functions that you can do is you can sum it, you can average it. 2 things that people usually ask: what is the total? What is the average? I think there's other ones as well. You can probably put in median. But those ones, yeah, you can just look that up. SQL, Python, like statistic commands. But the most common ones are sum and average. And let's see, same thing. Just know how to like add a new column. The math as, and then the actual name of the column. And then like adding a new column. So a group by column. So let's just see if this is correlating with what we did here. So you group them by the product ID. So this is what you have, product ID. And then you group them by the store ID. So for the store ID, just to go back to what that is. If you go to this guy, so you see you have three. Yeah, you have three IDs, right?
Mm-hmm.
So and then this store ID. What did we use to reference these ones? We use the store ID to reference them, the invoice and then the store. So the invoice has store ID. It's actually right here. The invoice has store ID, and then the store ID also has the store data frame also has a store. So when you connect them, you're gonna see them here, and then they're gonna correlate with the product ID.
Okay.
Yeah.
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 Okay.
So that one makes sense. And then the thing is, what you did is you did the product ID first, which makes sense. It's in. I'm gonna talk about ordering them next, but pretty much that's what we did here. We ordered it by product ID, and then the next thing is we ordered it by store ID. So for each one, there's gonna be, for each individual product ID, you're gonna have an individual store ID that's designated for each row. And then like, whatever the associated ones are, these ones we didn't really add them as like a criteria for grouping them. All right, just to breeze through like the three variable one. So same thing, store name, and then the product ID, and then the store name, store ID, product ID, store ID, store name, and then this other one is the sum and average. But as you can see, it's very easy to group them this way, right? I think if I learned this first, I think this would be easier to learn, to understand than doing the one in like pandas. Pandas is a little cryptic, but then like since you learned that first, I guess it's easier since you learned it first.
Yeah, well, I actually liked pandas though.
Yeah, no, that's what I'm saying. Like, pandas is the one that everyone uses. Like, you need to know like 1 + 1. You need to know pandas that way.
Oh, okay.
And then matplotlib and pandas are the two ones that like you have to be. There's by default you have to be pro with those. SQL, it's like niche. If you know it, that's good. If you know some of it, that's good. You don't have to know all of it. So, but
Okay,
yeah,
I'm at like 20% with SQL.
that's
I wish
good
it
enough.
was more, but I actually like SQL. Like I was okay with it.
It is easier. There's not much things. I mean, it's just it's easier to understand. I think. Like I said, when you read this, like, oh yeah, it's easily interpreted. You add it. You add it. Even adding the columns is easily interpreted. Like, I know what's happening here by just looking at this.
Mm-hmm.
And like, by looking at like this joining thing, like, oh, okay, that makes sense. And then like you can put it all in one place. It's kind of like if you I guess I won't talk about it, but like R is another language. This is kind of like what SQL is doing. SQL has like a similar syntax as in a different language called R. But Python, the way it does it is it likes to do it where you call out. Python is really based off, like pandas itself is based off like, do you know how to manipulate a list? Because you have so many brackets, right?
Mm-hmm.
And you just run around and try to like understand what is being passed, and then until you get the data that you want filtered out. So that's why we touched on lists a lot, because like list is the main thing with Python when you're working with pandas is you have to understand the language of manipulating a list. Okay, so now okay, we'll end with this one, but if you look at the doing the order, like now you learn how to merge them. Now you learn how to like group them. But what about actually like like ordering it, sorting it? So the way you do it is just right here. it pretty much just tacks it on. Like that's the funny because like this thing can go on forever, I guess.
Yeah.
It just tacks it on at the end of it. It's kind of, I mean, like, you did the join and then you did the group by after that, and now you're just gonna put in the order. So
Mm.
so like yeah, so let's say what are we ordering this by? We're gonna order this by the store ID. So if you take a look at the store ID before, I don't know if this is the same one. Product ID, store ID, it is the same one. That's good. So if you take a look at the same one, the same data frame that's not organized, you look at the store ID, right? It's not organized the way. When I mean by organized, like is it ascending?
Oh, okay.
Yeah. So it's descending. This one is descending. And then like if you want to order it like ascending, you just do it this way. If that's something you like. If it's I think there is a way maybe to make it, to force it to become, like having the syntax by default will make it ascending. Kind of like with pandas, right?
Yeah, with pandas, you just do dot ascending or dot descending.
Yeah, like ascend. I think ascending equals true or false, something like that.
Yeah.
Yeah. Like with that, it's I mean, yeah, I like it that way. It's easy. I think this one you could also do it. There's a different like thing that you can put in here, where you can like force it to become descending if you want to. Okay, does that make sense? All of this is just like the most basic things that you need to know with SQL, Python.
Yeah.
Yeah, and then all the other stuff is just okay. Let me look towards that, and then maybe look at the documentation. All right. That's actually like I wanted to cover this in the last bit. The first machine learning, k-means clustering. Have you heard of this before?
Probably.
Okay. So I guess you guys will cover it. I know you guys will cover it because it's the very first thing. There's a bunch of them, and that's why I think I'll probably. Do you have time to watch like videos? If anything,
Yeah.
Okay, I'll send you one thing because the video for these machine learning, it has more things in it than anyone can ever tell you, like in like a class setting.
Okay, yeah, send it. Because I can watch it while I'm sitting in my daughter's first grade class trying to.
Yeah, I know you always know what it's a good time killer, yeah.
Yeah. Because I honestly I used to never play on social media. Now it's like, okay, there's no more social media to play on because I go through it all.
So
So if you can give me videos to watch instead, and I can put my headphones on and just sit there and watch and yell at her when she's acting up, then that'll work.
I'll organize them so that like you have one for k-means, you have one for SVM. There's a bunch of other ones.
Okay, cool.
Because like yeah, each one is like it's all on its own. It's a class. K-means clustering. You can learn this in like a class.
Oh, okay.
It's really crazy. Yeah, I know. But then the machine learning world, they have these weird names for them. So prepare yourself for like these weird names: k-means, SVM, neural network, and then the three basic things in machine learning is like supervised learning, unsupervised learning. This is like the arcs, the three arcs of like machine learning, and reinforced learning. And then I think there's three other ones, but they're not pretty common. And then the whole reason why you do machine learning, right, is so that you can predict something from existing data, right?
Mm-hmm.
And then so that you can teach a computer to act like a human, pretty much, and then make a computer do what a human would do by teaching it how to learn. That's why it's machine learning. You're teaching a computer to learn from a set of existing data, so that like once enough data has been like learned, it will automize whatever you would do as a human to like either organize, which we call classification. The second thing that it can do is regression. And then regression is like, oh, is there like from like different humidity, can I predict the temperature? And then from stock market, different types of like existing data, can I predict what the stock index is of the next day? And then there's like different things. There's so many different things you can do. And then maybe like the other thing, so that's what you call supervised learning, is you have existing data, right?
Mm-hmm.
And then you have this existing data that you can teach a machine. And then you can, and that's what you call supervised. That's why it's called supervised, because there's something there that you can base it off from. And then the other thing, unsupervised, is there's nothing that you base it off from. There's no existing data. You just have to like organize it. You have to organize data without any means of like referring back to like an existing data. And so what you can do, and this is the guy, the k-means clustering is what belongs in one of the algorithms that belongs in unsupervised learning. Because unsupervised learning, what you can do, since you have nothing to base it off from, is you can just group things. There's no particular grouping, because you don't know if they're like red or if something is white. What does it mean to be like a giraffe versus like a horse? What does it mean, right? You don't have any label to classify it. So it's just gonna do some type of like grouping, and it's gonna learn how to group them or cluster them without any particular like criteria of what each grouping is going to be. So that's unsupervised. Reinforced, so supervised, unsupervised, reinforced learning is really the one that's like the harder one, because then it's like you have an existing like criteria for what it means to be a horse or what it means to be a giraffe, what it means to be hot in a particular temperature or day, or like what it means to be cold. But then you're adding stuff to it. So like reinforced learning is like supervised learning, but you're adding stuff to it. That's why hence reinforce. So you're adding stuff to it. But I think the easiest one is unsupervised, if anything, because then it's like the bare bones ones where you don't need anything. Give me something. I'm gonna look for a pattern in like the data you gave me, and then I'm gonna group them in a particular way. Does that make sense?
Yeah.
Okay. So like that's like this idea of like clustering is not classifying, because classifying is you have you have a label, like defined label for what it means, and you're just gonna fit everything that comes your way to that label. Clustering is I don't have anything to fit it into, but I'm gonna figure out a way to group them. And then this K right here is just the number of clustering. So K is the number of clustering. Means is like obviously the mean in statistics. It's the average.
Oh, the average, yeah.
Yeah. So like I said, a lot of this has underlying statistics in it. But like, I'm gonna try to skip that and just tell you like how to run it. Like kind of like the main things that they will talk about. So K is the number of clustering. Means, the reason why I call this means is this thing, the k-means clustering, since there's no label to base off what you're clustering or grouping, it's gonna find the middle or centroid. Now, have you heard of centroid before? Like a centroid is just a middle, right? It sounds like a middle center.
Yeah, it sounds like middle ground, like a centrist. Yeah.
Yeah. So like it finds the center. So like let me give some like a bunch of code. Let me like actually show you some pictures. So we're given this particular data, right? These points can be like temperature, it can be anything. It can be like observation of like heights of a giraffe or an animal, an unknown animal that you don't know. And then like they're all a bunch, and there's no label here because this is very general. So this can be height, this can be like weight, whatever it may be. And so they're all scattered. There's no particular grouping, you don't know, right? So what ends up happening with this this k-means clustering is it's gonna pick, like for example, if I ask you how many different like groups do you see in here? Like if I were to ask you how many k clusters do you see in here?
How many dots or just the colors?
Not clusters, like groups of dots. If you were to group this by your own like mind, not a computer, how many different groups would you group this into?
Oh, shit. Can you hold on 1 second?
Yeah.
Can I call you back in a few minutes? Okay. Thank you. Bye.
Okay.
Sorry.
That's all good. Yeah. So like, yeah, how many different groups do you think?
I would say 1, 2, 3, 4, and then I would say green and red are like their own. So I would say 6.
Okay. Oh yeah, that's good. You see, so you know what you did there? Like you kind of gave it some rules, right? You gave it some. And then you said 6 because it seems like there's 1, 2, 3, and then on its own. So there might be 6. So you can, like what you just said, that number 6 is the K number, the K guy right here, this K.
Okay.
So with k-means clustering, there's 2 ways of doing it. You could either guess the number of K, which you did, and see what ends up happening, your output ends up to be. So what if you put in like 6, I don't know what this guy actually did, but let me see. So maybe like 1, 2, 3, 4, 5. So like they grouped them by, like whatever number, and then I think the dot right here, the dark dot,
Mm-hmm.
is the, because the centroid, it will pick a centroid for your cluster. So after you pick the number of groups, it will find the center of that group, and then see if there's a bunch of points around that center. So that's why it does it. So you find the number of cluster, you find the centroid of that cluster, the middle of that cluster, and then like see if there's a surrounding points around it, and depending on like the distance between that centroid and the dot. So like for example, if this is the centroid and then this is the dot that you
Yeah.
don't know, depending on that distance, there's a criteria that says, okay, with this particular distance, this belongs to this cluster. If it goes over, it's not going to belong to this cluster. It's going to belong to this guy, right?
Oh.
This guy's this cluster. It's going to belong. This guy can't belong to this guy. It's too much.
Yeah.
So whatever number cluster you have finds the centroid. It measures the distances from that centroid to the particular points, and then those will it will get measured. So the distances of those, the distances from the centroid to like each one of these guys. I think they did like three different ones. Like I just mentioned, this guy, this guy, this guy, and it measures it. And then like the thing in the end is you want to minimize this distance. Yeah, obviously. Like if you minimize the distance, that means that it actually belongs to that dot, right? To that cluster, right?
Mm-hmm.
Because minimizing the distance means that it gets closer to the centroid. So when it gets closer, that must mean that it's part of that group. If it's too far, it's not part of that group. It's part of another group.
Yeah.
So when you minimize that, and then that's why you have to test it. Because then, what if using only one? What if you only had one? You're gonna have really high distances, right? If you only had one cluster, you're gonna have so many distances.
Yeah.
So for a fact that because the name of the game for here is to have as many clusters, the minimum number of clusters where you can minimize that distance. So the minimum number of clusters where you can minimize that distance. That's what you're trying to do. But like I said, you have to guess the number of clusters. That's the first method, right?
Yes.
But there's actually a way, like say for example, this is them pointing out the centroids, and then like you iterate it until you find like, oh, what is the minimum? But what you're trying to do is there's actually another, say, and the iterated, now it's getting closer. Now it looks like there's actually 3 clusters, right?
Yes. Okay.
Yeah, and then so pretty much like the first method is guessing the number of clusters, finding the distance, and then checking that number. You can check the distance, which we'll talk about another time. But like the one thing I want to say is the package to do this in Python is sklearn.cluster. So sklearn is the main guy, as I mentioned, scikit-learn.
Yeah, I think we did do something like that in Python like a while back.
Oh, good. Okay. So scikit-learn or sklearn is the main package, and then like all the different algorithms will just have .cluster, .svm, . So and then this is the main. Anyways, so the first method is we'll reiterate it again next time with like some examples, but the first method is pretty much like guessing the number of clusters. The second method is you don't even have to guess. You can actually optimize the number of k. You can do some math, and then you can do some graphing, where you can guess. You don't have to guess, but you can like calculate the optimum, the minimum k that you need, so that you only have to run it once. Doesn't that sound better than the first one?
Yeah.
Yeah, because you can actually just why do you need to iterate? Like we want it to be so efficient where you only run it once. So that way, the thing is you have to write another like maybe a few lines more code to optimize it. Where the quick and dirty way is just guessing a number of k, and then looking at the outputs, and then once you see like, oh yeah, it seems like the distances are really short or are really small, so that must mean this is the optimum number. The other way, which I'll send you the video, so that you can know what the heck you can relate what I said, whatever the video talked about, is the second way of doing it is elbow method. So they call it the elbow method. The reason why it's called the elbow method, there's no there's no graph for it, but I'll just draw it with my mouse. But anyways, when you create the elbow method, like it's a bunch of code that you have to write, and it will graph the on the y-axis, it will graph the the distances I was talking about.
Mm-hmm.
So the distances is actually called the sum. There's two, but the one that we're going to talk about is called the inertia distance, or where it's the sum of squared errors. So sum of squared errors. And in the sum of squared errors on the y-axis, you have to minimize that error. So like the shorter the distance, the smaller the error, right? The shorter the distance, the shorter the error. So
yeah, okay.
This distance pretty much means it's an error. If it's too high of an error, that's not the right guy. It belongs to the other guy. If it's a short distance, small error, that's why we're minimizing the distance, because the distance is actually the error, right? The distance itself is actually the error. The distance from the centroid to the particular point. So when you minimize that distance, the graph looks like, do you remember, I guess it's a parabola. The graph looks like a parabola in essence. It doesn't matter though. But like, so once the graph is just this curve that I'm trying to draw. So, yeah.
What's that curve called? He said it in statistics. Oh, I can't remember the curve.
You mean the bell curve?
Yes.
Yeah.
Yes.
It's kind of like, it's not the bell curve though. Yeah, I know which one.
Oh, okay. Okay.
It's not this guy.
Oh, okay.
The reason why this is called an elbow is it's like the elbow. If you look at your elbow.
Oh, okay. Yeah, I see what you mean.
Yeah. And then this is the graph. The graph itself is, so this is the error. And then this right here is the number K. So now you can probably see it. This is the error. And this is the K, right? And the cluster. So what we want is to minimize the error, right?
Mm-hmm.
So we want to, where's the error minimized? Where it's almost flat. It's right here.
Okay, and that's on the three oranges.
This is the three, yeah.
Yeah, the three dot oranges just at the 40 line.
If you don't want an error, maybe you can pick this guy, but what's the point? Like, what this guy means, if you pick it all the way here, like maybe this is like 20 points, yeah? What this means is you have 0 error, but this means you have every dot has its own cluster. You don't want that, right? That's stupid. Why would you want every dot to be a cluster? You didn't get anywhere. You didn't group them, right? It's pretty much the same thing. If every dot is its own cluster, you didn't group it, did you? You didn't. So that's why you don't want this guy. People are sometimes like, if you want to minimize the error, why don't we just pick this guy? we want the optimum, so that's why we pick the guy where it's almost flat, but not all the way to the end. So if you pick something like this, and after, we'll talk about an actual example. When you have, and this is like maybe a 3, you get 3. So there's 1, 2, and 3. And you run your code and you get this. Does that make sense? That's pretty much like the bare bones, like maybe like the concept of k-means clustering, unsupervised learning.
Yeah, no, I get it. I kind of follow it. Yeah.
Yeah, this is probably like the easiest one. It gets harder from here.
Oh no.
Yeah, I know. It's fun. This is actually like, if you think about it, it's like, what do we use this for? You can use this in so many different ways. Like, like maybe like, I wouldn't say it's not used that much. Maybe an unknown like fruit, unknown medicine. Maybe, I don't know. Or because like if you have a label already, like for example, if you want to organize oranges and apples, you know what an orange looks like, right?
Yeah.
You know what an apple. So that's not unsupervised. That's supervised, because you know what is
okay.
An apple. What does it mean to be an orange?
So supervised is because you know what it is already. Unsupervised means you don't know what the outcome.
Yeah, you don't know what does it mean to be red? What does that mean? What does it mean to be blue? What does it mean to be green? These are arbitrary. We're just coloring it red because there's nothing else.
Gotcha.
Yeah, that's why hence unsupervised. Okay, Alisa. So yeah, let me send you those videos, and then this weekend might not be good for me, but I may, if
can we skip next week, because next week's the Thanksgiving week?
Oh yeah, I forgot. Yeah, exactly. But I will send you videos though, so that you can maybe watch them on your free time.
Yeah, that'll give me something to do other than listening to a zoo.
Okay, cool. Have a good one. I have another appointment. See ya.
Okay, talk to you soon. Thank you. Bye.